I think I left off with Ceres. There's, of course, Jupiter, a little more than 5 astronomical units from the Sun, and so forth, right? Notice Pluto, which is the inner edge of the Kuiper Belt, is about 30 astronomical units. Most Kuiper Belt objects we think is anywhere between 40 and about 50 astronomical units. There are probably some further than that. And notice, again, what we do is we use what we know best and we compare it. Like, for example, these are all these periods of the planets, of the orbit of the planets is compared to the Earth, right? So, for example, 1 Earth year would be exactly 1, and then 1 year on Venus would be 0.62 Earth years. Mercury would be 0.24. Mars is just under 2 Earth years. All right. Jupiter, it takes almost 12 years to orbit the Sun. Same thing with the masses, right? So we're comparing the mass of the, this is 1 Earth mass. Mars is a little more than 1/10 the mass of the Earth. Notice Jupiter is 318 times the mass of the Earth. And of course, all the Jovian planets are much more massive. Notice the Sun, right? 332,000. There's more accurate digits that go in here. Anyhow, so it's more than 332,000 times the mass of the Earth. And then let's take a look at these densities. For example, notice the rocky inner worlds, including Mars, have a rather large density, and notice the density is in grams per cubic meter. And then this column, the density is in kilograms per cubic meter. So basically, if you take the grams per cubic meter and multiply by 1,000, that's how you get kilograms per cubic meter. But this is the typical units that are used in astronomy and chemistry and physics as far as density goes. And the reason for that is the density of liquid water is 1 gram per cubic centimeter. And so it's very convenient to compare the density of these various planets to the density of liquid water. For example, if we look at the inner worlds, including the Moon, notice they're all more dense. The Earth is the most dense of the inner worlds at 5.5 grams per cubic centimeter. And then when you get out to Jupiter, notice Jupiter is a little more than 1. Saturn's actually less than 1. So Saturn has less density than that of liquid water. Uranus and Neptune are right around 1 as well. So again, the densities of these Jovian worlds, or these outer planets, the 4 outer planets, is closer to the density of liquid water, but they're much larger. Like, these are much more massive objects. All right, so those are some of the measurements that we've taken on these things. So let's look at the overall layout of the solar system. So you can kind of think of it as like a disk. The solar system is basically this relatively flat disk. It's not perfectly flat, but so it takes up, like the surface of a table. All the planets would orbit some point, which of course would represent the Sun, on a relatively flat plane. The exception to that is Mercury. Mercury is a kind of on a tilt, and so is Pluto. Pluto is actually on a much greater tilt than Mercury is, but we're talking about the planets here. Okay, so Mercury is a Kuiper Belt object. a lot of the Kuiper Belt objects are not in the plane of the solar system. So we'll talk about the plane of the solar system a little bit. You'll hear me mention that. So you can see, like, you look at this picture down here. There's this, like, looking at the solar system from kind of a side view. So notice Mercury is quite at a larger angle with respect to the plane. And I wish they'd show Pluto. Pluto is even more exaggerated, more at a greater angle. All right, let's keep moving. Because the planets are all in a relatively close plane, there are times, and this was one particular time in April of 2002, we see all the visible planets. These are the planets that were visible to the ancients, basically lining up. They're usually in different parts of the sky at different times of the year, but this particular time back in April of 2002, you notice there's Jupiter, Saturn, Mars, Venus, and Mercury. Mercury, by the way, is kind of hard to see. I've been looking at the night sky for a very, very long time, and Mercury, I think I could maybe 10 times in my life have I actually seen Mercury in the night sky, because or in the morning sky. It's really hard to see Mercury because it's so close. It's obviously the closest planet to the sun, so it doesn't. You don't see Mercury very far from the setting sun or from the rising sun. So if this was sunrise, the sun would be really close to the horizon, or sunset, the sun would be relatively close to the horizon. And so that makes the viewing of Mercury particularly difficult. All right, so this is a picture of the 8 planets and the sun in comparison. So they're trying to give you a sense of the size. Notice the sun is by far the most massive object in the solar system. It takes up like 99.9% of the total mass compared to everything else. So you compare the rest of the entire solar system, most of the mass is there in the sun. And then comes Jupiter, of course, the most massive of the planets, then Saturn, Uranus and Neptune, and then we get to the rocky inner worlds. The Earth, of course, is the most massive. The Earth has one natural satellite. We call it the Moon, although there are other moons around other satellites. Mars actually has 2 satellites. They're tiny little satellites. In fact, one of them we think is just a captured asteroid. Venus does not have any moons or satellites, and neither does Mercury. By the way, Venus is almost the same size. It's just a little bit smaller than the Earth. So it's kind of, as far as mass goes, the Earth's twin, although we're going to find out it's quite different from the Earth. So there's the terrestrial planets, also known as the inner planets, and then the Jovian planets. Remember, the inner planets, smaller but higher density. Remember, the Earth has the largest density, about 5.5 grams per cubic centimeter. And then the Jovian planets have a much smaller density, closer to 1. In fact, Saturn's is less than 1. But they're much more massive. Right? They're way, way bigger. So the terrestrial worlds are rocky, small worlds, as I kind of mentioned this just a moment ago. They rotate relatively slow compared to the Jovian planets, and they have, we think of the Earth's magnetic field. We use it to when you have compasses and things like that. But overall, it's compared to the other the Jovian planets, it has a relatively weak magnetic field. And there's just, the terrestrial worlds, there's only a few moons. There's 3 of them, basically. The Earth has 1, Mars has 2, and the ones for Mars are relatively small, little moons. The Jovian planets are large. They're sometimes called the gas giants. so these things have a lot of different names, right? Jovian, gas giant, as well as the outer, also known as the outer worlds. They're, of course, much further from the sun. So that, the thing that distinguishes the inner and outer worlds, besides density and mass, is that you find the Jovian planets beyond the asteroid belt. Right? The asteroid belt is between Mars and Jupiter. All right. They rotate quickly. The Jovian planets rotate about their, in some cases less. They take just a few hours to rotate about their axes, and they have very strong magnetic fields and many moons. I think Jupiter has over 60 moons, and all of the four, believe it or not just Saturn, have rings. Some of the rings in some cases can only be detected by very powerful telescopes. I mean, you can't see the ring, even the rings of Saturn, without a pretty decent telescope. All right. Now the differences among the terrestrial worlds. All have no, I don't know if I agree with this. All have atmospheres. Mercury doesn't really have much of an atmosphere. I mean, it's pretty thin. It's almost exposed to space. Venus, however, has a very dense atmosphere. In fact, the atmosphere of Venus is about 100 times the density of. And we'll talk more about that when we focus in on Venus. But its atmosphere is poisonous. It's carbon dioxide. It's not breathable for humans. But there's a lot of it. Mars also has a carbon dioxide atmosphere, but it's very thin. It's extremely thin, and that's because, of course, Mars has much less mass. The Earth is the only one that has oxygen. That is the O2 molecule, right? Two oxygens bound together, in a molecule. And of course it has liquid water on its surface. So Earth and Mars actually spin almost at the same rate. That is, they take around 24 hours to go around their axes once. Mercury rotates much slower, and Venus rotates much slower, and Venus is kind of strange. It's actually what we call a retrograde rotation. That is, all the planets are going around the sun. I mean, this is true about all the planets. They're all going around if you were to look down on the solar system from the north, they're going around in a counterclockwise direction. But most of the planets are spinning in that same direction. But Venus is one of the exceptions. Venus is actually spinning the other way. It's actually spinning about its axis, even though it's moving around, orbiting the sun in a counterclockwise way. It's going around its own axis clockwise, which is kind of strange. We really are still trying to understand that. We'll get more into that when we do the chapter on Venus. Only Earth and Mars have moons, as I mentioned before, and only Earth and Mercury. Mercury actually has a pretty good magnetic field. It's not like super strong or anything like that. All right, so let's see how am I doing on time? Okay. Again, if when this runs out, I'll just pick that up in the next video. You might have heard of this, the gravitational slingshot. So when a spacecraft gets close enough to a planet, the gravity becomes very strong, and that can actually change either the direction or the speed, like accelerate. In other words, it can accelerate a spacecraft. So it'll go from one velocity to a greater velocity, and also to change its direction. So we've used that actually for many years for especially spacecraft in the outer parts of the solar system. Although we